All right, 12.4, solving quadratic equations. Okay, I'm going to draw 3.
Well, then wait, why does it say rate? Oh, wait. Never mind.
What was that?
Nothing. I was confused by what it says on the board and what you're writing.
Yes.
That's for Thursday.
All right, 3 coordinate planes. And I'm going to give you a second to think of a parabola. We know that it's U-shaped and it has a vertex, which is also the maximum or the minimum, and it opens either up or down. And it's x to the second power, and it could be plus 7, it could be plus 9, could plus 2. All right, so knowing what the graph looks like, how many x-intercepts are you going to have? Think about it for a second. Think about it making its U-shape. How many x-intercepts? Any thoughts? Yes. Good observation. She said, doesn't it kind of depend? Okay, anyone else? Yes?
Isn't that infinity from like wherever the minimum and maximum is coming from?
Okay.
It literally doesn't stop.
Okay, so you're saying it's going to go on forever.
Yeah.
Okay, and I'm asking how many times does it cross the x-axis? That's the question I have.
Oh,
how many x-intercepts?
2.
Once. I heard 2.
1 or 2.
1 or 2, and that's what Christina said, it depends. All right, 1 or 2. Is it possible to have more than 2?
No.
No.
Is it possible to have less than 1?
Yeah.
Less than 1.
Less than 1 would be what?
Nothing.
Nothing. Is it possible to have no
It would
x-intercepts?
be not possible.
It's not possible. Okay, so let's check. I'm going to draw the first one. I'm just going to draw a parabola.
Not possible.
Do you agree that that parabola has
That's
2
it.
x-intercepts?
Oh yeah. Oh yeah.
Okay.
Oh, yeah.
I'm going to call this 2 x-intercepts. And another way to say this, I'm going to put an or, 2 real solutions. And I use the word real because there will be imaginary solutions that we deal with later. Okay? 2 real if you have 2 x-intercepts, that means you have 2 real solutions. All right. Now, you guys said it could happen where it's 1. For example, if I put my vertex here, and it doesn't matter the direction, I'm going to put it all the way down. Is this parabola ever going to come back up and cross the x-axis?
Nope.
No. So this would have how many x-intercepts? 1 x-intercept. Or how many real solutions?
1 real solution.
1 real solution. All right, I want to talk about this one over here. We said 2. Is it possible for a parabola to wrap back down and cross again? Yes. Is it? Not for a quadratic. You will have problems in advanced math or even in math 3 where the graph does that, but it's not going to be a quadratic graph. Quadratics always go up forever or what? Down forever. They don't wrap around and come back down. Again, like when you get to math 3 or advanced math, you will have graphs that do that. They go and they bounce back. So that's next year's. Next year's. All right. Okay. Yes. Is it kind of cold?
No, I think it's quite temperate.
It's perfect in here.
Guys, let's pipe down. Apologies if it's kind of cold, but I leave it like that because it's hot 7th period. And it's yeah. Christina's sitting in the coldest spot in the room. That's where it hits.
Who wants to switch?
Can a parabola go sideways or something like that?
A parabola can go sideways. That's next year's math class. Yeah, that's next year's. You will have sideways facing parabolas. They're not called quadratics. All right. Listening up here. Thank you. Okay, last one. I'm going to put my vertex right here. Guys, enough. I'm putting my vertex here. If I wanted to have no x-intercepts, would I open it up or down? Up. Do you guys agree if I open it up right there, it's never going to touch the x-axis?
Yeah.
Now, that's not the only possibility. I could have, if I wanted to, put it anywhere down here and done what? downward. Okay? I need the talking to stop, gentlemen. Okay, so how many x-intercepts would I say here? This would be no x-intercepts or 0 x-intercepts or no real solution.
Okay, so it's just how many times the x-intercept?
Exactly. How many times it crosses the x-axis is considered your x-intercept or intercepts. So the only possibilities for any parabola is it has 2 x-intercepts, 1 x-intercept, or no x-intercepts. There's never going to be more than 2. Got it? So this one here means it has imaginary solutions. All right. Questions on this?
This is really easy.
We're going to solve them today is what we're doing. Okay, so that's what we're going to try right now. We're going to solve and state the number of solutions. Solve and state the number, and I'm going to replace the number of solutions with the word number of x-intercepts. Is that pretty much the same thing? 2 x-intercepts, 2 real solutions, 1 x-intercept, 1 real solution, no x-intercepts, no real solution. Is it the same thing?
Indeed.
Yes, number of, but we are going to use the word x-intercepts. All right. Number 1. 2x squared minus 5 equals 0. How is this different from the ones we've had last week? It wasn't 0 last week. What letter did we have here? Y. Either y or a function which we called function notation, which we called f of x. F of x or y. Okay, so we haven't seen it with the 0. Now that we have, we're getting ready to solve. Solve it like you would a standard equation. What would I do to both sides? Add 5 to each side is what I heard. 2x squared equals 5. And then we would do what?
Get rid of the square.
Before I get rid of the square, very good observation, but before I can get rid of the squared, I heard divide. We have to divide first. And when we divide, we don't do the opposite. We just divide by the coefficient. So what are we going to divide by? 2. Gone. Leave it in fraction form. Do not change it to a decimal. X squared equals 5/2. Now, Caleb said get rid of the squared, and that's what this step is going to be. And how do I get rid of a squared? What do I do to both sides? Square root. Did I hear radical? Square root. If it was to the 3rd power, I would cube root both sides. But since it's to the 2nd, I'm going to square root. Now, we've talked about this a few units back. I don't put the 2's here, but do I know it's there? Yes, that's why we call it square root, because there's a little 2 in there that we don't need to write. All right, what happens with the square root and the squared? They undo each other.
X.
They undo each other. Those are called inverse functions. Inverse functions undo each other. And I'm left with what?
X.
X equals. Now, there's going to be 2 tricky parts here. First tricky part I do want to take my time to explain. Plus or minus. First off, can I reduce the 5 over 2?
You
No.
cannot.
I cannot. Plus or minus root 5 over root 2. I'm still not done. Before I continue, I want to address the plus or minus. Have we done that before in this class?
No.
I don't think we have. We have square rooted both sides before, right?
Yes.
And I never had to address the plus or minus because every time we did this, we were solving for the length of a side. And when you're dealing with the length of the side, the length is always positive. We didn't have to do the plus or minus. But I want to explain why we put plus or minus. Are you guys ready? If I had x squared equals 25, how would I solve that? What would I do to both sides? Square root, x equals, what's the square root of 25? And I'm saying now to put what in front of it? Okay, and here's why. Let's check it now. What's positive 5 squared? All right, what's negative 5 squared, meaning negative 5 times negative 5? Is it still 25? Okay, so can you see why we need to put the plus or minus? No? Ask me a specific question.
Why do you not?
Okay, where we didn't have to before? Okay. I will address the why we did it before, but let me first address why we do it now. Do you agree that, for example, x squared equals 36? Without square rooting both sides, can you tell me what number you could plug in for x that when you square it, you get 36? 6. Does everybody agree with that? But is that the only solution? No. Why not? What else would work? Negative 6 squared is still 36, is it not? Yes. So whenever you square root both sides, you do have to write plus or minus whatever that square root is.
But it's the same answer, isn't it?
Positive and negative, they're opposites. They're not the same.
But it
That's,
turns out the same.
Yeah, but they
That's
still
what
end
he's
up
trying
to
to
be
say.
36 positive.
they come out to both be 36 or both 25, but you have two solutions. That's actually where your two x-intercepts are coming from. That's where they're coming from, this whole plus or minus business. Why did we not have to do it before? Because we did it when we were dealing with problems like this, right? And we did a squared plus b squared equals c squared. Do you guys remember that? And when we were doing this, we were solving for the side lengths. And would side lengths ever be negative? So we didn't have to deal with the plus or minus then. But now that we're dealing with x-intercepts, like look at this picture here. Can x-intercepts be negative? Yes, yes it can. Got it? Questions on that one? No questions? All right. So back to the not being done. Why is this not done? Who remembers what I'm not allowed to have in this problem?
Radicals in the denominator.
Good job. Radicals in the denominator. Does anybody remember the process? It starts with an R.
Rituals.
Rituals. Rationalize. I heard some of you start to say that. Rationalize, which means we multiply top and bottom by a radical. And which radical do we choose? 2. Okay. A few things. Why root 2 over root 2? We've talked about this before because root 2 over root 2 is equivalent to what? 1. And 1 was that word that you guys struggled with, the multiplicative identity. All right, so when I multiply by 1, am I changing the value or just the way it looks?
Just the way it looks.
Just the way it looks. All right. Now, why root 2 and not root 5? Because what is root 2 times root 2? 2. And does it get rid of the radical in the denominator? Plus or minus, what's root 5 times root 10? And they're both radicals, so you are allowed to multiply. Did I say it when I asked? Sorry. Root 5 times root 2 is root 10 over, and then root 2 times root 2 without saying 4 is 2.
Why did I say
All right. Now, if you want to write root 4, that's fine as long as you change the root 4 eventually to a what? Can I reduce the 10 and the 2?
No.
Why not?
One's a root and one's not.
One's in a radical and one is not. You guys are correct. This is my answer. All right. Even though it looks like one answer, really it's how many answers in disguise? 2. There is a positive root 10 over 2. There's also a negative root 10 over 2. So how many, even though it looks like 1, it's really how many in disguise? 2. Should you know that?
Yes.
Yes, because they ask you to say, state the number of x-intercepts. How many would there be? 2 x-intercepts. All right, so there's 2 answers here, this and this. And I really want to quickly talk about why are these x-intercepts, because I haven't addressed that yet.
How are there two? Sorry.
X plus or minus, x equals plus or minus. The positive 10 root 2 is a solution, and the negative. Yeah? Got it? Okay. Backtrack up here, you guys. Whenever you plug in 0 for y, is that what we did? We took out y and put 0? Yes or no? That means you are finding x-intercepts. Don't know if you knew that before, but you need to know it now because we're going to be talking about this a bit in just a little bit. If you ever take y and you take out the y and in its place you put a 0, you're looking for the what? x-intercepts. Does that make sense? When you have x-intercepts, you're not moving up or down. That means y is 0.
Oh.
Do you see that? Okay. Let's try another one. Number 2. 5x squared plus 100 equals 0. Okay, look at the last one, how we solved it. What would I do first here?
Subtract 100 on both sides.
Good job. He said subtract 100 to both sides.
5x to the second equals negative 100.
Correct. Good. 5x to the second equals negative 100. Do I square root both sides or divide both sides? Divide. Square root should be the last thing you do unless there's parentheses. Divide, 5, gone. X squared equals, what does that reduce to? Negative 20. And what do I do to both sides?
Square root.
Square root. Are we allowed to take the square root of a negative number?
No, so it's unsolvable.
So it's unsolvable, so we'd say no real solution. And we use the word real because there is an imaginary solution, which we'll learn more about in the weeks to come. For now, no real solution. Yes. What does that mean about our x-intercepts? How many x-intercepts do we have? None. No x-intercepts. So you have 2 answers here. No real solution, no x-intercepts. That means your graph is something like, say this one here. This is a graph we did earlier on. Do you see how this graph here has no x-intercepts? Can you guys see that? It's been shifted up 1. Is that graph ever going to touch the x-axis? No. And if you look at solving it here, how would I solve that here? What if I was looking for the x-intercepts? What would I plug in for y? I just said it earlier. 0. Do you guys agree?
Yeah.
0 equals x squared plus 1. How would I solve that? What would I subtract? The 1. There's nothing to divide. So negative 1 equals x squared. What would I do to both sides? Square root. And can you take the square root of a negative? What does that mean? No real solution. What else does that mean? No x-intercepts. And can we verify that with the graph? Okay. Is it somewhat coming together? Yes? All right. I'm going to move this aside, and we're going to try another one. Number 3. 0 equals parentheses x minus 3 close parentheses squared minus 21. Okay, what's a little different about this one? Parentheses. And it still has the 0, but it does have parentheses now. I'm just going to cover this for right now. If I were trying to simplify this, am I allowed to do minus 3 or negative 3 minus 21? Can I combine those? No, because the negative 3 is trapped inside the parentheses with a with the squared. Do you see that? All right, so I'm going to ask the question again. Can I combine these two terms? No. All right. When I'm trying to solve, what am I going to do with this guy first? Plus. Plus is correct. Because he's not trapped in the parentheses, we can get rid of it to the other side. And what do we get? 0 plus 21 is 21. All right, this next part is tricky. It's tempting, and it's very tempting to add what to the other side?
21.
To add the 3. Well, we did it before. Why can't I do it? Why am I not allowed to add the 3 to the other side? Parentheses with the what? Exponent. That minus 3 is trapped right now where it's at. There's nothing I can do to it because it's inside the parentheses with the squared. What tools do we have to get rid of a squared? We talked about this earlier. What can I do to both sides to undo that? What is it? Square root both sides. So this time I'm square rooting early because the minus 3 is inside the parentheses. All right. What do I put here? Should I not forget in front of the root 21? Plus or minus. And what happens to the square root and the squared? They undo each other. All right. Now that I've undone the exponent, can I now move this 3 over? Look at the problem. I have no more squared. Can I now move it over? Yes? Do I have to add it over or divide it over? Add it over. I'm going to show you the easiest way to write it. I like to write it with the 3 in the front. Bless you. Get used to writing it that way now, because when we get to the quadratic formula, that's how we're going to write it. This exponent right here. When I square rooted both sides, square roots and x squareds are inverse functions. They undo each other. And that's why we did it, so they would undo each other. All right. We write it like this. 3 plus or minus root 21 equals x. Why can't I add these together? Because one's in a radical and one is not. The same way earlier when we couldn't reduce them over here. All right, so that means this is your final answer. It looks wonky, but technically this is a decimal. You could plug in your calculator and come up with an answer. 3 plus root 21, the calculator would give you an answer, a decimal answer. 3 minus root 21, and the calculator is going to give you a decimal answer. So is this a number I can plot on the number line?
No.
Not right now the way it's written, but can I plug it in my calculator and get a decimal that I can plot on the number line?
Yeah.
Yes. And if I were to do this, if I were to do 3 plus root 21, get a decimal, I'm going to write that down. If I were to do 3 plus root 21, get a decimal, 3 minus root 21 and get a decimal, how many x-intercepts would I end up with? Good job. 2 x-intercepts. Do you see that? The number of solutions is equivalent to the number of x-intercepts. Do you see that this would be 2 solutions in disguise? So 2 x-intercepts. All right, so one more just quick reminder. When I move numbers over and I have a radical with a plus or minus, the number goes first, the plus or minus radical goes second. Do you see that? All right, questions here before we move on. Math is beautiful. That's what it is. All right,
Math is torture.
number 4.
21 Savage Pilots.
All right. Gentlemen, guys, pipe down. Ladies, let's listen. Okay. Number 4.
How many more are we doing?
We have a few more because we still have to graph some. All right, stop the talking. Enough to keep us busy. All right. I want to solve this. What am I going to do first?
Add the minus the 35.
Minus the 35. Everyone's following me.
Absolutely.
Gone there. Negative 5. Parentheses, x plus 6 quantity squared equals negative 35. All right, I haven't seen one like this. This one has parentheses and a coefficient. 2 questions for you. 1, can I subtract the 6 right now?
No.
Because it's trapped. Can I distribute the negative 5?
Yeah, no, you can't.
Why not? Because there's a what here?
I mean, the exponent.
The exponent. All right, but I don't want that negative 5 there. Anybody know what I do first? Get rid of the negative 5. How? Adding or dividing? Why dividing? Because it's negative 5 times. You know what your assignment is, yes? Okay. All right, so what do I divide both sides by?
Negative 5.
Now it's gone. You do not want a square root if you have a coefficient. Either like this here, like the 5x squared, you want to get rid of that 5 first. Or in this case, the negative 5 with the parentheses, you want to get rid of that negative 5 first. All right, x plus 6 quantity squared equals, what is this reduced to? Positive or negative? Positive. Now, do I subtract 6 or square root both sides? Square root to undo the squared. Square roots, squareds, undo each other. That leaves me with what on the left-hand side?
X plus 6.
X plus 6. Now, can anybody tell me where I messed up? Yes. No, not sure. No one's catching it. I would definitely get this wrong. Okay, I'm going to continue. Yes. The plus or minus. Good job. That's one of the biggest mistakes kids make. They forget their plus or minus, and especially when you haven't been doing it for a long time. But you want to make sure you recognize you only do the plus or minus when you're solving an equation and you yourself square root both sides. I want to repeat that. You're solving an equation and you square root both sides. Got it? All right, what's the next step? To subtract what? 6. Now, do I put it at the end or in the beginning? I told you guys earlier.
The end.
What comes first? The beginning. All right, so you do -6 plus or minus root 7. -6 plus or minus root 7. So, good job. All right, okay. Everyone see how we got -6 plus or minus root 7?
Yes.
Can I plug this in the calculator and get a decimal answer?
Yeah.
-6 plus root 7, -6 minus root 7. If I were to plug them in, how many different decimal answers would I end up with? 2. Good job. 2 real solutions, which means 2 x intercepts. Can you guys see that? You do not have to rewrite this if you can see that it looks like 1, but there's 2 in disguise. Does that make sense? All right. Number 5, and then we're going to move on to a word problem. 0 equals parentheses x plus 2 squared and then plus 12. 0 equals the quantity of x plus 2 squared plus 12. I'm going to let you guys try that one on your own. I'll give you guys a few seconds head start. Go.
Come on, it's. Nothing.
Yeah, 19 probably.
That's a lot of hope.
That is not. All right. What can you guys at least give me your first step?
Let's just do the even.
Subtract 12 from both sides.
Good job. Guys, we're paying attention. -12 equals the quantity of x plus 2 squared. Is there any coefficient here that I have to divide over? 1, which doesn't count. Okay, so what do I do to both sides?
Square root.
Square root. Good job. Square root to undo the squared. Can I take the square root of a negative?
No.
We cannot, not with real numbers. We haven't learned imaginary. So it's no real solution, which means how many x-intercepts? None. No x-intercepts. And we've looked at a problem already. We looked at graphs that have no x-intercepts. All right, are we good? Okay, we're going to see an application problem, and then we're going to do some graphs.
So when you see that the square root is negative, automatically everything just goes out?
Yes, correct. So when you go to square root, be careful because this one was negative, but when I divided the -5, it became positive. So at the point where you square root both sides, if you're square rooting a negative, you can stop and say no solution. You do not have to subtract the 2 and blah, 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 blah. It's no solution. Did you guys understand her question and the answer? Do you want me to repeat it, what she asked?
Yeah.
She asked, anytime you square root a negative, can you stop and say no solution? That means there's going to be no x answers. Correct. Did we even subtract the 2 at that point? No, we stopped and we said no solution because we square root a negative, which cannot be done. Okay, number 6. An application problem. Heads need to be up off the desk. And arrow is shot vertically upward. Heads up off the desk, guys. With an initial speed of 64 feet per second. Its height, its height after t seconds is given by h equals -16 parentheses t minus 2 close parentheses squared plus 64. Period. When does the arrow hit the ground? Okay, do you guys agree the arrow is going to go up, 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 reach its maximum, and then come down, 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 and eventually hit the ground? Yes or no? Okay, so I'm just going to get a quick picture here. What is the X? Instead of X, what letter do I have? What letter do I have in the X spot? T. And what does T stand for? Time. And instead of the Y variable, I have an H. And what does H stand for? Height. Okay, which way does this shift? Right here, this shifts right or left to? Come on, guys.
Right.
Right 2 and up 64. And which way is it facing? Downward. All right. So you have this parabola. I'm sorry. Yes, you have a parabola. You have this arrow that's going up, 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 reach its max height, and then comes down, 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 down. You're looking for it when it hits the ground. Do you guys remember what we called that point when we were selling pizza? That was the point where we what? Broke even. What does that point represent here?
Hit the ground.
Hit the ground. Now think about, what is your height when you hit the ground?
0 feet.
Height equals 0 feet. When you hit the ground, do you agree your height is 0? Yes or no? So if I'm trying to solve this without the graph, how am I going to use this? What can I plug in for H to find at what time does the ball hit the ground? I'm going to repeat the question. I want to know when, that means I'm looking for time, the ball hits the ground. What can I plug in for H to find the time when the ball hits the ground? Anyone? Plug in what for H? Plug in what for H?
0.
0. Do you guys agree when it hits the ground, the height is 0? Yes or no? You need to understand this, guys, so make sure you do your homework tonight because this type of question will be on the test. Would anybody like me to repeat why I plugged in 0 for H? Yes.
My question is, how is it only a height of 2 after 64 seconds? Oh, 60. Never mind. I had it backwards.
Okay, so yeah, so at 2 seconds, it's a height of 64. Yeah. All right, are we good? Okay, so solve. How do I solve this?
Subtract 64 on both sides.
Subtract 64 on both sides. And what does that give me? Negative 64 equals negative 16 t minus 2. I cannot square root yet. What do I have to do first? Okay, do what here? Divide or add?
Divide.
Divide by negative 16. That's good because what's going to happen with those two negatives? Cancels out. Does anybody know what 64 divided by 16 is?
4.
4. Good job. 4 equals t minus 2 quantity squared. What do I do to both sides? Square root, square root. What do I have to put in front of the square root on the front of the 4? Plus or minus. I'm going to switch spots. I'm going to put the t minus 2 on the left side. Square root and radical undo each other. T minus 2 equals plus or minus what? What's the square root of 4? 2? No radical on this one. That's nice. And what do I do? Oh, I said it, but I didn't write it. Plus or minus. And what am I going to add to the other side? plus 2. T equals positive 2 plus or minus 2. Now, I'm not going to leave this one because there's no radical, so I can actually, are these like terms, is my question. Are these like terms? Yeah, so I can actually work it out. What's 2 plus 2?
4.
And what's 2 minus 2?
0.
Okay. Obviously, the ball hits the ground once. Which one am I going to take, the 0 or the 4?
0.
Which one am I going to take, the 4? What do you think the zeros, what do you think this one stands for? When it started, went up, came down. You'll always get 2 answers. How do you know which one to cross out? It's either going to be 0 or negative. I'm going to repeat that. One of them is going to be 0 or negative. So you cross out the 0 or negative. Everybody hear that? And then you take the positive answer. So how many seconds does it take to hit the ground? 4 seconds. Okay, we do have one more to get through, but since we have all the legwork done, it's not going to take that long. Oh, wow. Okay, this is what the first section of your homework's going to look like. Okay. I know. What number is this? 8, 7? Oh, shush. Okay. 0 equals, sorry. 0 equals x plus 3 squared minus 4. Okay. How do I solve this? Add the 4. Everybody with me? 4 equals x plus 3 quantity squared. What do I do to both sides?
Square root.
Square root. And what do I have to put in front of the square root right here? Plus or minus. And what is the square root of 4? 2. And I'm not going to write 2, I'm going to write plus or minus 2 equals x plus 3. What do I do next? Subtract the 3. And I'm going to put the x on the left side. X equals negative 3 plus or minus 2. Are these like terms? Then I have to work it out. Negative 3 plus 2, negative 3 minus 2. What's negative 3 plus 2?
Negative 1.
Thank you. What's negative 3 minus 2?
Negative 5.
Negative 5. I have 2 answers. X equals negative 1 or negative 5. That does not mean an ordered pair. It just means 2 solutions. This is part A. Part B is going to ask you to graph this exact same equation. So let's do a quick graph. Which way is this translating me? Right 3 or left 3? Nobody knows?
Oh, we're going to go right 3.
This is left 3 and this
my
is
bad.
up 4 or down 4? Come on guys, right here, up 4 or down 4? So left 3, down 1, 2, 3, 4, and is it opening up or down?
It's going to go up.
Up. And I'm going to plot those points, negative 1 and negative 1, 2, 3, 4, 5, because those are called the what? The x-intercepts. And can you see that it does come out to be a U shape that is symmetrical? Can you see that? 2 real solutions. Now, part C is going to ask you, what does this represent in your graph? And what do these 2 points represent in your graph? The x-intercepts. Okay, I didn't have time to write that down, but part C is going to ask you what? What do these 2 points represent in your graph? The x-intercepts. And if this was no solution, what does that mean about your graph?
It's not going to
It's not going to cross the x-axis. You would have no x-intercepts.